effects. This meeting is, okay. So yeah, so the reasons why this can be, what's it called? The reasons why this is an important question, I think, is because it's ambiguous, right? We don't know, like theory says that, as labor supply goes up, wages should tend to go down. That's kind of like the usual supply and demand model. But we start thinking about the dynamics of these things, and you start thinking about agglomeration economies, human capital externalities, you name it. It starts to paint a more nuanced picture, right? So that's kind of like where I'm trying to get at, like get an empirical effect that can say, this is what we should see, right? But then there's the obvious endogeneity problem that a lot of the literature has faced on this, is that labor flows are endogenous, right? So people move to places with better amenities, right? To places with higher wages. So everything's kind of moving at the same time. And the solution that I thought about to kind of address this is use location decisions based on weather. So the idea being that people will move to places with better weather. And we've been kind of seeing this with climate change and the more recent discussion on like climate refugees. So that's kind of like where this solution comes from. So the literature so far on this. So there has been some theoretical and empirical work on the importance of agglomeration economies. What's it called? Durant and Puga, Moretti, they have these like models where they say, this is why we would expect higher productivity in places with a larger workforce or population size. Some of them are, you have better, higher economies of scale or better division of labor, that sort of thing. But these are more theoretical papers, theoretical work. So mine is more empirical. The immigration literature has definitely looked at this. How do economies react to a shock of an immigrant shock, right? So, CARD has worked on this, or Ito has a very nice kind of survey paper on this as well. But the difference with my paper is that what I do is I estimate a dynamic path, right? So whereas these studies, they look more at static, like one period effects. So let's say a paper will do like the effect on 2 years, and then another paper will do the effect after 10 years, etc. What I'm trying to do here in this paper is really estimate the whole path of the, let's say, productivity, right? So how does productivity respond the first year, and how does that evolve over time? Same thing with wages and employment, right? And then, to do this, I will get into the methodology a little bit more in detail later, but I use a panel VAR, and there have been a couple of papers using this to look at migration as well. More notably, one of these two papers looks at OECD countries, and yeah, so basically what they do is a similar thing to what I'm doing in this paper is, look at all these like economic variables and then put, migration in, I think it's like the top ordering of the vector autoregression, and they solve this endogeneity problem by relying on ordering assumptions, which is, what people usually do in this VAR papers is use this Koleski decomposition. However, this relies on kind of ad hoc assumptions, right? So you have to, yeah, I think there's a hand raised. I'm not sure.
Yes.
Joel.
I have a quick question. Hey, Ale.
Hey, how's it going?
Good. I have a quick question because more about the wording. You are talking about agglomeration, and I'm not sure how this is entering here, because agglomeration, usually I think about big cities or like area like the Silicon Valley. Like usually when you talk about agglomeration, you talk about this type of effect. But I didn't see that much in our empirical facts. I'm not sure how you're using this agglomeration. Are you saying like if the city is larger, people be more attracted to it? Are you gonna use this or something like that?
Yes. So the analysis that I'm doing is yes, the empirical facts that I mentioned in the motivation were at the county level, but the main results are going to be at the MSA level, at the city. And I will. So what I do is that I introduce. So I include migration. So I include gross inflows and outflows of people. So that allows me to see how the net kind of population evolves over time, and the fact that I put it into a VAR kind of allows me to see how these two things interact with product like GDP per capita and wages, et cetera. So I can kind of gather, or I guess gather the how these things are kind of influencing each other. So that's how it fits into the agglomeration. So like, right, you have this initial shock of immigrants that are coming in, and the first response of GDP, let's say, goes up, but then that can have its own like feedback effect into the migration. So yeah, definitely trying to capture that as well.
Are you calling like then agglomeration as like some complementarity? Like if you move in, you're gonna raise also other people's productivity and wages? Is this the what you call agglomeration?
That's what I'm calling. Yeah, that's what I'm thinking about. This paper still doesn't have a, let's say, like a theoretical framework in mind. That's kind of like the next step where I want to take this for sure. But yes, that's definitely have like the idea that I have in mind for sure. Okay. People become more productive, and then they attract more people to come in, etc. Kind of like Silicon Valley. Yeah, it's a good example.
Okay.
But right, so what's been done in this in these panel VAR models or papers, sorry, is that they rely on these ad hoc, ordering assumptions. So basically saying like, oh, migration should influence GDP per capita, but GDP per capita shouldn't influence like past migration or something like that, like some variation of that. What I do to kind of, like what's different in this paper is I rely on exogenous instruments, right? So I don't need to kind of make these assumptions at all. And this kind of fits into the, let's see, the right. This fits into previous literature trying to identify these effects, these market size effects with exogenous labor mobility shocks. And notable example is Peters, 2019, a working paper, yes, where he kind of looks at, so post World War II Germany, they use kind of, he uses refugees coming in from, I think, like other countries coming into West Germany, and how that influences, what effect that has on GDP per capita, but also structural change, right? So how does industry evolve, with in respect to agricultural industry, et cetera. But so the difference here is that I'm using more recent evidence, right? So my sample is going to be, I'll show it later, it's from 2001 to 2014 when I merge everything. So that kind of allows me to have, more recent data, et cetera, better data, all that stuff that comes with more recent evidence. And right, so, and just to kind of conclude this slide, there has been some literature on the effects of weather on economic outcomes. So definitely, bad weather definitely has a negative effect on productivity at the micro and at the aggregate level. And there's this paper by Mullins and Parraguez that kind of looks at the migration response. Kind of, it's like the other side of this paper, kind of looking at, how does different weather measures affect people's willingness to move or leave their places of origin. Right, so that's kind of like an introduction, and I'm going to go into the econometric methodology that I'm using to get at these effects. Right, so like I said, the goal here is to estimate a structural impulse response function, because this will give me the dynamic path that I'm looking for to a migration shock. Right, so just for, like, let's say you have a destination I. This is let's think of a city. Let's think any your favorite city in the US in year T. And let's put all these variables in this VAR. So what am I including? I am including, like I said before, gross inflows of people from other counties from within the US, gross outflows leaving this city I at time T. And then I have these different, what's it called? These different GDP per capita, wages, and labor measure. So this is an employment, this is the employment to population ratio, or employment per capita, right? So those are the variables. Just assume that they kind of follow this linear VAR1 process with time and destination fixed effects. And then we have, so when I run this, I get the usual reduced forms UITs. But let's see, but these are not the structural shocks, as we know, right? So what I want is really to kind of shock this destination I with a 1% migration shock, and then see how everything responds. Unfortunately, the UIs, these reduced form errors are not, they're all kind of correlated with each other. That's the endogeneity problem. That's kind of where it shows up, right? So if we, let's say we assume that there is this vector of structural shocks that are not correlated with each other, right? So this epsilon IT, and it's related with this residual by this B matrix, right? So this is where, going back to the panel VAR papers that I was mentioning, this is where they kind of use this Kolesky decomposition, and they say, okay, migration has this kind of lag effect on GDP per capita, but future GDP doesn't affect migration. So we can have this ordering, make these ordering assumptions, and then we can kind of recover this B matrix, the whole B matrix, by using the Kolesky decomposition. Now, here, this is where it kind of diverges, is I don't need the whole B matrix, right? What I'm interested in is a migration shock. I'm not interested in a GDP per capita shock. I'm not interested in a wage shock, right? What I want is to recover the first element, the first entry of this epsilon vector, right? So to do this, I don't need to get the whole B matrix. I just need the first column of the B matrix. And this is where, okay, so let's see. And I also need the deltas from the AR1 process, right, to calculate the impulse response function. But the question is, how do we find this first column of the B matrix? And so how do we find it? This is where the kind of the SVAR IV methodology comes in. So I use instrumental variables, right? This is following a Stock and Watson paper. Here, let me just go here. I think it has the reference, yes. So basically so if we assume, if we normalize, right? So we would do this like just normalization, saying the first entry of this column is 1, so that, the one effect, I think it's like 1% structural shock is equal to 1% residual shock. I think that's the way to think about these things. Right, if we normalize this, then we can rewrite using the residuals, the reduced form residuals, we can rewrite them, the relationship like this, right? So you have, this is the jth element of the Y vector. So just to kind of ground things, think of J as GDP per capita, right? So this is GDP per capita at IT. And then you have, your gross inflows of migrants coming in at IT, and this is going to be the immediate effect of that shock, of that migration shock, right? And then you're controlling for the other variables in the Y vector in a lagged in the previous period. You have your usual fixed effects, but here there's still the endogeneity problem, because these are a combination of the non-migration structural shocks, right? And we know that, because of what I was saying, like migration responds to amenities, it responds to higher wages. So we know this is going to be correlated with, with this E element. So you can't just do a regular OLS. You need an instrument, and following Stock and Watson, you need an instrument that is correlated with the migration, the structural migration shocks. So basically it's pushing migration into these counties or cities, but it's uncorrelated with the other non-migration shocks. So it's uncorrelated with GDP shocks, it's uncorrelated with wages, and it's uncorrelated with employment shocks at the destination level, right? So remember, this is looking at the city that's receiving the migrants. Okay, so the steps are estimate the panel VAR that I was showing the previous slide to get these delta ones or their estimates, and then estimate this equation, the first equation in the slide, using 2SLS for each element in the y vector. But then we have a new question: what instruments do we use, right? And this is where weather comes in. Okay, so right now as the paper is, I use a Bartik style instrument, using like weather as a push factor. And what this means is basically, you observe, take your favorite weather measure, let's say precipitation. You observe precipitation in county J at time T, right? And this is going to be pushing migrants away from this county J, right? That's the assumption, right? But then there's also, this is weighted by the pull factor, right? That's usually used in these shift shares instruments. And this is what I'm kind of following the literature on immigration that uses these instruments. Basically, this is the migration share of migrants coming from county J into city I, but at a pre-period, right? So the idea being, okay, so in the migration literature, they use this, and the idea they're thinking about is, let's say, you have places that had a big immigration from, let's say, Latin America, right? In a previous period, let's say the year 2000, like before your analysis, they're going to tend to have a higher migration rate or immigration rate in the following periods, right? Because there's like cultural attachments, et cetera, like links, network effects that kind of pull migrants into these city I's. So that's the instrument, right? You just kind of take this weighted sum, you take the logarithm, and then you have your ZIT. So, and this is where the assumptions kind of come in, is this instrument, the ZIT, is going to satisfy the relevance assumption as long as weather affects location decisions, and the exclusion assumption if weather outside the destinations doesn't impact structural economic shocks, or is uncorrelated with structural economic shocks in the destination, right? So to do this, I build instruments, using temperature, wind speed, and the number of extreme days, which is kind of like a measure I did to capture like extreme variation in the weather. Right, so the data, let's see, okay, 1025. So the data that I get, so on the one part, migration and economic data, the migration data comes from the IRS, which provides county to county worker flows from 1990 to 2018. And what you see here is, so you can see households, and you can see individuals, and you can also see the total income that they represent, right? And for the economic side, or just like the GDP per capita, employment, et cetera, I get that from the BEA that has this at the MSA, so the city and the county level. And I define the migration rate, as usual, just total inflows divided by the previous year's population at the destination level, with migration outflows defined similarly. Okay, so for the weather data, this comes from the National Center for Environmental Information. I think they changed their name, but yeah, it's like part of the NOAA, the US NOAA, which provides station day level weather data. There is a hand by Daniela, I think.
Yeah, I just have a quick question.
Yeah.
First, thank you so much for the presentation. It's really interesting. I was wondering whether you are using any kind of control for the industry, because I think that different industries are located in different parts, and I think that the weather influences the industry. For instance, agricultural is the most obvious one, and that also will influence productivity, isn't it? And it will be correlated with the instrumental variable. And then, I mean, I think that, I don't know, I was just thinking that it could cause a little bit of endogeneity.
Yeah, so I don't, that's a very good question. Very good point. I don't control for industry directly. The only thing that I'm thinking about that could be kind of controlling a little bit for this is the destination fixed effects.
Yeah, no, I was thinking about that as well, but probably specific industry fixed effects will be necessary, or I don't know. What do you think?
Yeah, no. That's actually that's a good point. That's a good point. I hadn't actually really thought about that in detail, but yeah, that would be ideal to kind of control for, like you said, agricultural, but also thinking about the tech sector, for example, in Silicon Valley. Like, yes, that's a very fair point for sure. No, definitely gonna have to include that. Yeah, thank you for your point. Yeah, I see another hand raised. Juan.
Sí, hola Alejo.
Hola.
Hi. Yeah, thinking about the same point that she did, maybe even if you don't have information about the industry, you have information of the GDP. I don't know how disaggregate this, but you can kind of control of the shares of employment or the share of production that each county has, for instance, for agriculture, because for the other industries, maybe it's not that important. For places that are very industrial, you cannot think about that, but you can like kind of control for the the share of production that each county has in like using your GDP data if you don't have like information on the employment.
No, I have to double check, but I think the BA does provide this employment by sector.
Yeah, like exactly. So you can exactly, you can kind of control if you have employment is much better because, but if not, you have two options, like use your GDP data or the employment data to control a little bit for that.
And should I control for that on the at the VAR stage? Like that would be kind of, I guess that would be the second stage of the because the
issues that you're in your instrumental variable, right? Like the instrumental could be correlated with type of like the effect on the weather with things that you don't see, like the share of the employment on each one. But
I see. Okay, now it's more okay. Perfect. Yeah. So it's the it's a problem on the exclusion restriction. Yes. Okay.
Yeah.
Yes. Perfect. Okay. No. Yeah. Thank you both for that's a really good point. I actually haven't thought about that in detail, so definitely it's gonna be part of the paper as it gets improved for sure. Thanks. All right. So where was? Oh yeah. So the weather data. This is from the NOAA. It comes. It's station day level data. So you get really kind of precipitation, wind, etc. at the station level. So what I do is I aggregate it to the county. To the quarter level, take daily averages or sums depending on the variable, and then I take it to the county level using a mapping that the NOAA provides. And yeah, as you can see, most counties have just one observation. So taking averages is not a huge problem. Okay, so that's the data, that's the model, and let's look at some of the results. So first, let's look at the kind of cumulative response of the migration variables, right? So the first row, the top row, is migration inflows, and the bottom row is migration outflows. So how many people are leaving the destination, right? And on the left, you have counties. On the right, you have metropolitan areas, right? So this is, let me see if I can zoom in because the numbers here are a little bit bad, a little bit small, sorry. Right, so we can see that, both, so after a 1% migration shock, people tend to arrive more in the future to these destinations. They also tend to leave, right? So this could be happening for a lot of reasons. People perceive that their job opportunities are being kind of, there's more competition for jobs, so they tend to leave. I don't know, that kind of story. But the interesting thing is that on the net, population tends to increase. So migration responds on counties by 4% in the long run, and then by 3% in cities. Whereas for outflows, it's not even 1.5% or 3% in cities, right? So on the net, population tends to increase. So this kind of goes back to the agglomeration discussion. Like these cities tend to receive more people in the future after a 1% increase in migration. And then for the economic variables that are in the VAR, they're all positive responses. So GDP per worker increases, wages increase, and the employment to population ratio increases. So this kind of lens suggests that there are some positive, externalities going on. And not just that, they're dynamic. So kind of going back to the Peters 2019 paper, the model that he has, there's this kind of, there's this mechanism that he talks about that's about how a larger population size helps, the entry of new firms, and that has like dynamic effects. There's like a dynamic elasticity that on the one hand has positive effects on the economic variables, but on the other also has this, it makes the population distribution kind of, persistent over time, right? Something like that. Right. So, but in counties, by destination size. So that's kind of like the sub question. You remember the research questions. The first one was, what is this effect? What are the dynamics effects? And then the second question was, how does this vary by population size? So, from this slide, so this is showing you counties' response by, let's see, so by population size. So this is low, medium, and large counties. And the same for metropolitan areas, right? So what I kind of want you to take out from this slide is that it's mostly, just from the significance, from the bands, the 95% confidence intervals, we can see that it's, medium to high to large counties and small to medium cities. So it's like really like, it's like medium-sized economies, if you will, that are driving this effect. So that's pretty much it. So yeah, that's kind of the. I think I'm just on the time. So those are the results that I get so far, and of course there's remaining work, right? So I didn't kind of go into detail, but we can talk more about this on the in the Q&A. I guess, but there's a weak instruments problem here. For the sake of transparency, the results that I showed used destination fixed effects for the IV, but I didn't include time fixed effects because the problem is that when I do include the time fixed effects in the IV, the strength of the instrument kind of goes down, and this makes sense when I think about Mullen's paper on the response of migration to weather. Basically, what they find is that people don't respond so much for random, shocks in weather. So, for instance, in Austin, we had a pretty big snowstorm at the beginning of this year. I think, yeah, it was the beginning of this year, and from that paper, you wouldn't expect people to move just because of that one shock, right? What they do find, though, is that people do respond to long-term changes in weather. So, and this has to do with their expectations. So people start seeing like, oh, this is a recurring pattern. So let's say in Austin, we get another snowstorm next year, and then another one like stronger than the year after that. Then you could expect people to move just because their expectations of where the weather is going in this local economy is changing over time. And let me see if I can, oh yeah, it works. Okay. So this, you look at the instrument that I built, but you difference it by different lags, right? So you just take the log differences. You can see that, here, okay, so what am I showing you in this table? This is basically saying, all right, let's difference it by 1, 2, and up to 8-year lags, right? Let's look at what the immediate effect is on GDP per capita. And then let's look at the F statistic on that IV regression, right? But this is including the time fixed effects, right? Whereas before I was just showing with the destination fixed effects. So you can see that, it's below the kind of 10, the rule of thumb threshold that we usually think about. But once you start getting into like higher years, kind of like 6 years for temperature, it's like 9, it's closer to that rule of thumb. Precipitation is 15 after for 5 years. And I think I have it here, right? And you just use like regular differences, not logged. You can also see kind of the similar thing. So 11 here, and then for wind starts to become a little bit more. Right here, you can see like 10, 8. It's like becomes stronger with these differences. But yeah, that's kind of like the main weakness of this paper for sure. And there are other sources of bias. You have to control for weather expectations. There's an unbalanced station panel, and of course you have to control for other flows between origins and destinations, right? So this, so the exclusion restriction could be affected not just by what you guys were saying about the sectoral shares, but also just trade of goods and flows of capital. If you have a huge hurricane in New Orleans and there's like a lot of trade between New Orleans and Houston, then you can expect that Houston will suffer from those effects, and you can see that in wages and GDP per capita for sure. So after I fixed all of that, the idea is to kind of think about a theoretical framework and start aggregating this, right? To start looking at macro effects. So what happens if, because of climate change, you have a flooded city tomorrow, people move to other places, like what happens on the aggregate? What about technological shocks, right? So like you have these like, let's say tech shock that kind of affects San Francisco more. How does that affect migration from other places? That kind of stuff. So that's kind of where I want to go with this paper. And yeah, the rest is just appendix. So I will open it up to questions. But yeah, thank you for listening. And yeah, that's it.
Thank you very much, Alejandro, for your amazing presentation. Does anyone has a question? Okay, so I'll go. I have a couple of questions. Can you show me the instrument again, please?
The instrument, yes, of course. Let's see. Here we go. Okay. Okay, so I was thinking that, have you seen the author paper about China and imports and exports? That maybe because their instrument is the change. It is not per se like the amount, but the change. So maybe you can get some of that flow. And maybe you can see also the paper from Elora Deroncourt. She said she does. So she had this amazing paper about migration and how migration created mobility, social mobility on Black communities. And she also has this kind of flow instrument. She doesn't do like an amount, because here I can see like you do the share, but they do the change share, something like that, similar. So maybe you can take a look on both. Is this so they use the change in the share or the change in the pushback?
So I don't recall that well, but maybe you can take a look on both.
I'll take a look at the paper. Yeah, for sure.
The David author is the famous one on China, and the Laura one, she's kind of publishing on the American Economic Review, so maybe you can take a look. I will send you the link. Definitely.
Thank you for the I definitely want to take a look at that for sure. If anyone has any more questions.
I
There's
guess
something
no.
in the. No, I guess yeah.
Alejandro, sorry, I had to leave for a few minutes in the end,
Sure.
but I was
Yeah.
wondering about this satisfies relevance if weather affects location. Did you show some data here, or is just
No, so it's in the so that would be on the first let me see where I have it on the first stage, because I kind of here we go. So let's see. So this is kind of yeah, so it's the only evidence I kind of show about this is the F statistic to kind of show how strong the instruments are. So here what I do is basically look at the different instruments. So the instrument built with different weather variables. So here in the first row, you kind of see temperature, then it's precipitation, wind, and a number of extreme days. So I kind of estimate the first stage with what's it called? With these all four, I mean, separately, and then all four together, and then kind of like look at how the F statistic moves around to see how strong these instruments are. So what I end up using for the paper is just the precipitation and the number of extreme days instruments, because those were giving me the higher F statistics. They were the stronger instruments. But what I was saying is that if you note here, this IV only contains destination fixed effects. If I look at, well, yeah, this is the, okay, let me just zoom in here. If I use just regular IV without any fixed effects, the instruments are not that strong. Well, some of them are, but you know, when you look at cities, it's not that great. When you use destination fixed effects, that's what I was showing earlier, and that's the baseline for the result, for the estimations. But then when I include year fixed effects, which is what I should do, because my panel VAR includes them, and it makes sense because you know you want to control for like aggregate, like macroeconomic shocks, etc. Then the strength of the instruments kind of falls down. Yeah, so that's kind of what I was. So you know, if I were to use the same set, I only have like a 0, 9, and 3, right? So definitely have to work on this, and this is like the next step for sure if I want to say something relevant about this. But the thing is, right, so what I was showing is that, let me see if I, oops, here we go. So let's see, it was, where was this? Here we go. So no, what I was saying is that there's this, the literature on kind of weather and the effect on migration says that migration responds to long-term changes in weather, right? So when you look at, you know, a lag in this instrument, that's when the F statistics starts to kind of go up, right? Actually, not so much for log difference, but when you just use regular differences. So this is basically like the same instrument, but instead of using the level, you just use the change, right? In the weather. And you can see like for wind, it's most noticeable, right? So when you look at changes in 1 year, like it doesn't seem that people are responding that much to changes in like how strong the wind is. But if you look at, you know, 4, 5, 6 years, then this kind of F statistic goes up. And it kind of makes sense because, you know, people are kind of incorporating into their expectations that wind is becoming stronger, I guess. Maybe they start getting, I don't know, more storms or something. But yeah, no, definitely that's kind of where I need to go. I'm also thinking about using other, I didn't include it here, but what I'm working currently is using other instruments. They're based on just like population growth rates, birth rates, that kind of stuff to see what works, and give it more strength at the same time as I kind of try to strengthen these weather instruments for sure.
Okay, but okay, so sorry to take more time of everyone, but I'm curious, like, what's your story then? Like, what you're thinking? You want to get something that makes people move to another location,
yes,
and use, and you're thinking about just weather, right?
Yes, right now it's weather. Right now it's weather. It's the story is that, you know, people. So there's like a set of counties that are sending people into, let's say, Los Angeles, and these counties are hit by weather shocks, however I define them, like just the level, the long difference, etc. And that makes them move to Los Angeles, let's say, and that's kind of like giving me that exogenous variation.
People getting out of Minneapolis, pretty much Minnesota or something like this.
Or people going into Minnesota, they like
because
colder weather.
Yeah. Okay. So people have a preference for weather or no? Just a shock.
It's like it incorporates, I think, and that could be an issue actually, because it incorporates not just preferences for weather, but also how weather has an effect on productivity in these areas, right? So if you get like a
okay, so it's
okay. Let's say if you get a hurricane, for example, like you're not just moving because you don't like hurricanes. You're moving because there's like loss of jobs, loss of productivity, etc. Now, and that's what I was saying, that could be and that's another source of bias right here, is that if the origin and destination are tied by trade or capital flows, etc., then that weather shock is going to affect, the economic variables that I don't want it to affect. Yeah.
But then I would say that maybe you're looking at extreme events, no? Or you're looking, because here you're looking at any variation in temperature, any variation in wind, right? But
yeah. So I didn't go into, I have it here. So let's see. So I do look at
about this. Sorry, I'm sorry if you already mentioned.
No, actually I didn't go into the detail of how I constructed the weather variables. Let's see, where are they? Oh, variable construction. Here we go. So yes, like you said, I use average temperature, total precipitation, and wind speed, and that's just like level, just like variation. But I also build this measure of extreme values. Basically what I'd say is, okay, let's look at the county that's sending migrants, and let's look at the number of days that they've experienced quote unquote extreme weather. How do I define extreme weather? Well, it's basically just a 2 standard deviation change or relative to the average across the sample, right? And that's so I get, that's how I identify a day with extreme weather. It's like, let's say precipitation 2 standard deviations above the average, and then I count the number of days for that station, and then I just aggregate it up to the county, right? So yeah, that would be my measure. Another thing that I was thinking is using just the variance of these weather, like temperature, precipitation, just because I'm guessing people don't like when weather fluctuates so much. So maybe that could provide something, some strength for sure.
I would like to see, it would be good to complement this with some like case study, like a hurricane in a hurricane event, or like
right,
polar vortex in Minnesota.
Yes.
I don't think anything was destroyed. It was more like weather related.
It's just a weather thing. Okay.
It's more like this gets very cold. But it would be nice to get these examples and see. Because usually for this type of studies, I see more like case studies like this.
Yes.
There was a catastrophe or something. People move out, and what happened in the cities where these people enter. Okay. And here you are taking everything. Yes. And I'm not sure what you're capturing there. Like it is, if the temperature increases a little bit or decreases a little bit, maybe it's actually going against you if you want to capture.
Yeah, that's the I think that's actually in the signs that I would get. At first I was getting like the weird signs like, oh, people who like extreme weather, they're moving into extreme weather places. So yeah, no, what you're saying is completely right. And so you were thinking about just kind of putting some cases there, or just like more.
I mean, I'm not even a econometrician, so I actually don't know. Actually, I don't know how to put this in run. But I think the story would be about something about
something like that.
Something about putting like controlling for these extreme events.
Gotcha.
More than just a variation like 2 degrees more or 2 degrees less, or rain a little bit more, rain a little bit less.
Yeah.
Maybe you won't get any variation out of that, and it might
kind of
and then it doesn't help much, right?
Yeah, but no, I think it's something that should be in there for sure, to kind of ground things more. Definitely.
I think you would be more cool. But it's very super cool. Very nice.
Thank you. But yeah, I don't know if other people have more questions.
Thank you very much, Alejandro, for your presentation. And we will see each other in 15 days. Have a nice day, everyone.
All right. Thank you so much, everyone. Bye-bye.